Hey everybody, welcome back to Deterministic. I'm Brandon Konkle, and this channel is where I explore different ways to embrace more determinism in our programming, bringing more predictability to our daily lives. Today's episode of the Rust Review covers 6 different articles over the last week and a half in the Rust community, including an announcement from the Rust style team that, hey, they exist again, an introduction to the Rust, or the cal type in Rust and how it can be useful, a look at nextest, a library using Tokio for async concurrent testing, and deploying Rust on Deno. So I'll start out today with the announcement from the Rust style team. This is a post on the official Rust blog that talks about the Rust format tool and how having a standardized style was something that was really important to them. And so they formed a committee back in 2016 to 2018 to help standardize what the formatting tool would do. And this is something that I really appreciate. Coming from the JavaScript world, there are a dozen competing style guides and various tools to enforce and automatically format the code for you. But there are also a lot of people with big, strong opinions around these tools. Some people hate them and fight against them. Some people really have unique style preferences. And I've always pushed for the adoption of an automatic style formatting tool to simplify writing code, just to eliminate that entire train of thought around style, because it distracts away from what your code is actually doing. So I feel like automatic formatting allows you to eliminate that as a concern, because you'll always know what to expect because the code tool is always formatting it for you so that you don't have to think about it. The fact that this Rust style team and the Rust format team has made this feel almost like a solved problem in Rust, I think is a huge benefit to the ecosystem for me. So like I said, it was originally formed around 2016 to 2018 and then disbanded. But since then, we've seen a number of changes that have, or a number of things that have required changes to Rust format. And the development team has expressed that they want to stay out of those decisions. They want to stay out of those debates and focus on implementation rather than opinion, which I totally understand. Sometimes you really love the mechanics of working on this tool and how it does what it does, but you're not necessarily as interested in making those meticulous style decisions and debating the back and forth of different approaches until you find something that works for the most number of people. It makes sense to have a separate team that focuses on this. So I think making it a top-level concern is a really good thing, and they can focus, the Rust format team can focus on writing the very best code that they can and giving us the best tool that we can. And then the style team can focus on figuring out what that tool should actually do and taking the community feedback and driving their goals long-term for the tool based on what they're hearing from the community and the consensus that they're trying to reach with it. Sounds like a really exciting thing. All right, so next up, I'll talk about cows. So I don't know, some of you, especially if you're new to Rust, you may not have even seen the cal type yet, but I've definitely seen it in open source projects that I've worked with and didn't necessarily know what it did. So the fact that Constantine G, I'm not going to try to pronounce his last name because I'm horrible at that, but he posted an article this week highlighting the cal crate, mainly because, like he says here, it's a mystery, even for some intermediate level Rust developers. So I'm definitely living proof of that I've not actually worked with it or really knew what it did. I've just seen it in open source projects around. He jumps into explaining the cal type and how it can help you avoid extra memory allocations for better performance in your code. Memory allocations are not cheap. They are definitely a source of many common performance problems in code. And if you can avoid it, then all the better. So the first example that he pulls up here has a method that modifies borrowed data. So this remove whitespace takes a borrowed string, a slice of a string, a reference to a slice of a string to be really specific, and then calls toString, which clones the string and creates it again in an owned memory region within this function. So a memory region that the function can fully control, and then returns that string as the result of the operation. So the problem that he highlights with this is that, what if the vast majority of the calls in this contain no white space? So there's no reason to allocate that memory to create an owned string so that you can call replace on it, because replace isn't doing anything. So he shows how the cow type can allow you to express or it can allow you to return either the same borrowed version or an owned version of the underlying type. Either or. It can be a reference or it can be an owned instance. And that's really powerful. Like in this case, he shows how you can check to see, okay, is there white space that this replace is actually going to act on before it actually makes the allocation? And if there's not, it can just return the borrowed version that was passed in. No harm, no foul. You can move on without any allocation. This owned versus borrowed allows you to return either or in your function, which can be really powerful. So with the next example, he uses a struct that stores references to a string and then uses cow again to avoid cloning the data unnecessarily there. But then with the example after that, he really goes into why it's called copy on write, why it's called cow. This toMute method that he points out is where the magic really happens. If it's called and the cow is owned, it just returns the pointer to the underlying data. But if it's borrowed, it clones it first to the owned form before returning the ref. So this allows you to lazily clone it only if you're going to mutate it. So if you don't call toMute, then it never gets cloned and you don't have to worry about it. He covers a couple of more examples in here, including using a custom type instead of a primitive inside the cow, borrowing the underlying type as a dynamic trait implementation, and then what was it? Oh yeah, implementing a wrapper around a foreign function implementation, so kind of a safe adapter. But yeah, it's a really detailed post. I would definitely recommend digging into it. There's lots of code examples and things like that. So exactly the kind of practical post that I love. Definitely check it out. All right, the next one's kind of fun. This is brute forcing zip passwords or zip archives in Rust. This is not something that I would encourage you to do to anyone else's zip file, but the author in this case, Arnaud Gourlet, a Rust developer working for Quadrant in Germany. In his case, he had a zip file containing family data. And rather than going with a sketchy third-party solution, of which there are many that look quite suspect out there, to gain access to this zip file that they didn't have the password for anymore, he decided this would be a great opportunity to learn how to do it himself. So he details his journey as he iterates through a few different approaches. He starts with a really large password file at first, sometimes known as a rainbow table or something like that. And implements multi-threading around it, and then discovers just how CPU bound this workload is when he works on ramping it up to more concurrent threads, and finds that really 4 threads was best. Adding any more threads after 4 really doesn't do much more to help the execution speed of the program. So he says, first off, it worked. He found the password. He ended up getting it to go, where does he talk about? Yeah, a little bit under 1,400 passwords per second, which is pretty awesome. But like he said, he really didn't find that more than 4 threads helped the performance, and he was confused because his thread was supposed to be an 8-thread machine. What he discovers is that his 8-thread machine was actually a 4-core machine using hyperthreading. But of course, when you have a very CPU-bound workload, hyperthreading can't help very much. And so really he was maxing out the 4 physical cores in his CPU, and that was why he wasn't getting much more performance going beyond that. He does improve the performance of the tool from that 1,300 passwords per second to about 4,500 passwords per second, which is pretty great. I'm sure there are more sophisticated approaches out there that are just screaming fast, but this seems pretty darn good to me for a fun side project to learn how to do it. He uses the Crossbeam channels library, which he says is far superior to the channels that are available in the standard library. And yeah, he does a great job of walking through how he approached this and how he measured success. And what's really great to me is how he goes into troubleshooting the performance, how he used the flame graph here to see where time is being spent and how the different tools that he used to analyze everything. This was really eye-opening to me. I loved the approaches that he took on here, and it's a great exploration of how to debug a performance in a CLI tool like this and how to see what's going on. All right, so next up, I'm going to talk about the nextest package, CargoNextTest, which is a implementation of CargoTest that uses Tokio for async behind the scenes and achieves better performance than the built-in CargoTest command is able to provide. There we go. So this is on the blog of Rain. Didn't have a last name. That's right. Okay. So Rain is a developer tools engineer in Oakland, California, and she is the maintainer of the CargoNextTest crate, which she describes as a next-generation test runner for Rust. It's definitely garnered a lot of attention. It's got over 1,000 stars on GitHub, and she says it's faster than CargoTest for most projects and offers additional features like test retries, reusing builds, partitioning test runs. And to do this, she uses Tokio, which definitely is my favorite async runtime. Digging into how Tokio works behind the scenes is really fascinating, so I'd encourage it if you haven't done so yet. But Rain goes on to describe how inter-process communication is a great use case for Tokio's concurrency model. If your application is heavily I/O bound, input-output bound, meaning you're talking to some other system like the file system or a network or things like that, that's an I/O bound workload, and CargoNextTest is likely going to be a pretty good fit for that. She talks about why this is the case by going into a concept called heterogeneous selects. This describes operations that observe two or more computations with many different kinds of sources. So this could be, reading from the file system. It could be a network response. It could be a timeout signal or a termination signal from the operating environment, or, lots of different kinds of environments with different kinds of signals with different kinds of types behind the scenes. And so selecting the first one of those that yields or that is done, that is what a heterogeneous select is, and it's what an async framework does really well to enable concurrency. You have multiple computations proceeding essentially at the same time. Often you'll have a wait time as you're working on one task, and then you set that task aside and work on the next task. There's a great deal of things in a test execution that you can wait for in a single-threaded concurrency-like situation. But what's great about Tokio is that it enables multi-threaded concurrency as well. So beyond what Node does with the event loop, it spawns threads and uses them in an efficient way to handle this concurrency. So it's a great way to handle multiple test processes or sub-processes as they are executing. Rain initially used a thread pool for this, but encountered difficulty with things like detecting slow tests and terminating them, or detecting sub-processes that don't get cleaned up at the end of each test. And so Tokio allows her to replace all of the tricky code that she had to do to deal with all of those with just Rust and Tokio primitives written in a declarative style, which is really exciting. She details the challenges with the original model and how Tokio helps it. And I love how there's expandable code samples, but the code samples start out of the way so that it doesn't ruin the flow of the post. The details and the diagrams that are included are really helpful. Her rationale around Tokio and why it helps so much is really interesting. This is a very detailed and informative blog post that I would definitely recommend you seek out and read through in its entirety. Next up, we have an Async UI library in Rust. So you're thinking, wait a minute, UI in Rust? This is a fascinating experimental project from Wisha W. Wisha is an undergraduate student at Rice University in Houston, Texas, studying physics and computer science. And he recently shared this new Rust UI library where everything is a future. It's called Async UI, and it's a proof of concept library that can target the web and GTK4, which is a widespread cross-platform UI library used commonly in Linux, but also in Windows and other environments too. This UI library is entirely based on futures. All the components are futures, but why? Wisha goes through why. Because UI widgets are retained, which means they can live for an arbitrarily long amount of time. So synchronous Rust lifetimes can't really express an arbitrarily long amount of time like that. But with async lifetimes, they can spawn across await points. And so await points can wait for arbitrary lengths of time. And so with the async feature, we now can express this arbitrarily long lifetime for UI components. So with this, the UI components become futures. They are composed with fragments. So composition is one of the first class concerns in this implementation, being able to group or contain multiple components together, and then awaiting the fragment awaits all of the components within the fragment. So kind of like a promise.all in the JavaScript world. I love that he decoupled the library from a reactivity model. He doesn't ascribe channels or signals or something like that, but he does link out to libraries that you can use to implement that. I just love the concept on this because I think the emphasis on ownership, lifetimes, and memory safety would go a long way to making the front end more reliable. This is Rust's unique approach to managing all of this chaos, as opposed to object-oriented or functional. Rust kind of borrows from both and does some things completely different. And I think doing this on the UI is really a fascinating idea, especially now that we're getting WASM frameworks and ways to really easily build JavaScript with Rust or things like that. I think if you could use something like this in a really strict way, this could bring a lot of the same kind of benefits that you see in systems like Elm or PureScript, guaranteeing no unhandled runtime errors. That was always an amazing claim. But with a sound type system used in a strict way, you actually can achieve that. I think Rust is generally easier to work with than the Haskell or the ML influenced systems like Elm. But approaching that same kind of safety with a different developer experience seems like a really big win to me. This is definitely early on. It's not intended for use in production, but it's a fun proof of concept of how this could apply to UI and the benefits that it could bring. And finally today, we're going to talk about Deno. So Deno is not something that you would normally see brought up in the context of Rust. But Matthias Lafelt posted an article on his Art of Serverless blog this week that introduces how you can actually take advantage of really exciting tools like Deno Deploy with Rust. So Matthias is a freelance developer. He has a special place in his heart for developer tools. On his blog post, he talks about how his previous post introduced a library called AWS Region Nearby that finds the nearest AWS region to a given location. I've seen tools like this in other ecosystems, and I've seen a Go tool that does this, but this is the first Rust implementation that I've seen. And with a library like this, you can make sure you're always reaching out to the closest global DynamoDB table to the instance that's running. So global DynamoDB tables are tables that exist in multiple AWS regions that automatically replicate to each other. With this, you can edge deploy serverless functions to multiple regions and then make sure that they're talking to the DynamoDB instance that is closest to them. The idea is that it'll lead to extremely fast and low latency data access calls in this edge deployed world. So in his post here, he explores the Deno runtime. This is an exciting isolate cloud distributed system, they call it. So an isolate cloud is based on V8 isolates. So they link to it in the blog post that Matthias links to, but it's a feature of the V8 runtime engine, which is a highly polished JavaScript engine. And these isolates typically run in their own thread. And as you can see, in the post that I just closed, where'd it go? As you can see, no, it's not. It's in this post a little higher up. There it is. So it's been described as the simplest deployment I've ever seen, with deploy times that are incredible. Just amazing kind of talk about how this new approach simplifies deployment. And it does that by not relying on a container or a VM, but using this isolated thread as the target. To deploy Rust this way, he deploys his Rust AWS region nearby library this way on this new Deno Deploy. He uses the, let me see if I can find it in the project. He has, it's a pretty short post, but he links out to some different things. There it is. This is what I was looking for. He links out to his GitHub repository and his change set that added the support for Deno Deploy. And you can see in the build, he's using wasm bindgen. And then here's his make file. He's building it with this wasm32 target and then calling bindgen. So bindgen is a tool that makes it easier to interact with the wasm ecosystem. It polyfills different features, allows you to interact with the wasm runtime environment from within Rust when you're compiling it down to a wasm target. So I didn't realize how easy it was to do this. I didn't realize that it was so simple to build server-side projects like this down to this WebAssembly target and deploy them to things that were originally built for TypeScript or JavaScript, but writing your code with Rust. It's really an exciting idea, and I think it can open up just really screaming fast deployments and execution times because you don't have quite the same cold startup penalty that you would on Lambda, for example, or something like that. Just really fascinating. I love that we're progressing serverless to the point where it's going beyond containers, going beyond like actually thinking about servers to things that are really low level, really super high performance that we really haven't seen in our daily work yet. All right, so that's it for this week. Not as many posts as last week, but there was definitely some interesting stuff going on in the community. But thank you for spending this time with me. I really enjoyed putting the articles together. Next week, I plan to bring in my first co-host, Alex Kaliris. He's the one who submitted the Async UI blog post this time. I work with him at Formidable Labs. He is one of our UK contractors that I've worked with on multiple projects now. He's got a great eye for innovation and kind of thinking outside the box, and he loves Rust and has been part of the reason that I got into Rust in the first place. His enthusiasm just rubbed off in a great way. So I'm glad to hopefully have him joining next week. If you are interested in development work, both on the front end and the back end, take a look at the company that I work with, Formidable Labs. They started out as the JavaScript experts. They've built up a really well-known reputation in the React world. But in recent years, we've expanded beyond that into the back end, into cloud infrastructure, into innovative new approaches in other programming languages like Golang or Rust. So I definitely would love to hear from you and see if there's a way that we can help you on your project. Thanks again. You can find me on Discord on a variety of different servers. If you go to my blog at konkle.us, you'll find different links to my various social networks and some great articles, especially around Rust and GraphQL. So thank you very much for watching, and have a great day.